Hi, everyone. I'm Tim Murphy. I work at ActionIQ. If you were at the previous DevOps-Exchange conference a month ago in New York City, that was our office. So, um, as I said before, this is my first conference talk, so go easy on me. It seems like a pretty big audience, so I'm pretty happy about that. Nice to meet you all. So, what are we here for? What am I here for? I'm here to talk about Jenkins. For those who don't know what Jenkins is, it is an automation platform. So, why am I here? There's a famous quote by Bjarne Stroustrup, the creator of C++. There are only two kinds of languages: the ones people use and the ones people complain about, and the ones nobody uses. This is true for automation systems as well. It's pretty much true for every piece of technology, but definitely true for Jenkins. Jenkins does have some thorns. Just as a disclaimer, I don't hate Jenkins. There are plenty of wonderful things about it. We have succeeded and thrived as a pre-IPO startup, even through the pandemic, using Jenkins. So it's not all bad. I've just kind of stubbed my toe a lot of times. And so I'm going to complain a bunch about it, but really it has provided a lot of value. It is not the worst choice in the world. It is something where in the right situations, it's great, but it is pointy. So sometimes you got to watch where you're holding it. So I'm going to go back, revisit some of our assumptions about why we chose the system and figure out maybe why they weren't the best assumptions. I'd like to go through some of our implementation challenges where things that maybe we didn't do quite right, things that we could have avoided had we had more knowledge or more time in the situation. Then I'd like to go through some usability support challenges, which are more like challenges we face with Jenkins itself. Things that maybe we don't have a better alternative kind of using Jenkins. And then I'll come back and review some of the lessons learned kind of aggregate what we learned along the way. All right, so our assumptions: large market share, extensive plugins, high agency. So large market share was actually mostly good. It's great to have tons and tons and tons of accounts out there of, hey, this thing doesn't work, what do you do? We have a plugin for that. We just see all these tickets. Many of them have been resolved, so we have resolutions for stuff. But with that extensive plugin library, there are a lot of cases where things don't necessarily work with each other. There may be plugins that are unmaintained. And so with this large group of people using the product, there are a large group of problems that have yet to be solved, have been discovered and unresolved. And I think the biggest of these three things that we didn't really account for was the high agency often means high effort, high complexity. It's not always true. I think the industry is actually moving towards developing tools where you do get more agency, more freedom to work, and need to put less effort into making it happen. Jenkins is not a new product, and it doesn't have that break of correlation. So what did we learn? As we were going through, we learned to trust but verify. When the community is using, a large community is using a product, it's a great place to start looking. Demo it, try it out first, give it a test drive. Make sure that even though everyone is using it, that it is truly useful for what you're trying. If you're a team of two, Jenkins may not be the best thing to work with. And when something is promising a lot of agency, make sure that you need it. It's not always the best thing. So while we were implementing, what were some problems? We were kind of forced off of one system because there was a risk of it not existing in the very near future. So we moved from another system to Jenkins in a very short period of time. We did not have a lot of engineers to make this transition. We didn't have a lot of Jenkins knowledge up front. So our scope of the migration project was relatively small. It did not include some relatively important things like a good scalable code structure. It did not include a testing framework for the Groovy we were writing. There wasn't CD for the Jenkins infrastructure itself. All of the management was manual. And we didn't really plan on making all this org-wide education for everyone so that they can learn to use the product in a consistent way with each other. Turns out in the long run, doing things the right way early on saves a lot of time and money. It would be great to be able to do things the right way up front. You don't always have the luxury to. In the times when you are rushed and you just got to get something to prevent the fire, sometimes going back and making a second pass is worth it. Many times it is worth it. And if you feel like you are being rushed, consider the options. Go back, see what you missed. See what you think is missing. See what new features you think you could add. See what you think was measure what you think was frustrating to interact with, and prioritize those things. Lastly, we kind of learned that we didn't have the headcount to make good use of the agency that Jenkins provided. That's less true now. We've been able to put a lot of work into our Jenkins infrastructure and get a lot more value out of it. But at the time, it might have been smarter to move on to something that was easier to move on to, something that required less work to actually get up to speed. So an example of a particular implementation challenge that we faced was the noisy neighbor problem. We had to figure out how to schedule our tasks into the containers that Jenkins was working with. So we had the option of spending more money, giving everything larger containers, wasting a lot of those resources, with the option of using smaller containers with soft memory limits. It ended up being cheaper, something more tangible for management. But occasionally things would collide with each other. You get these situations where we'd have these spiky memory requirements where sometimes they would fit together nicely and not cause any problems, but other times when they overlapped, they would blow the box up. If that happens frequently, that is bad. It means people have to do something about it, restart their jobs, debug something that they don't really know why it's running out of memory, especially if it's not their job that is hitting the limit. But if it happens infrequently, it can be okay. Sometimes you can live with this happening 0.5% of the time. Just restart your job, 0.5% of the time it works. Cool. The other option is container sizes by job. Figure out which job needs these larger memory requirements and assign those. You kind of get this problem where people may not know how much memory their job requires, so they, give it a little bit extra. They say, well, yeah, just give this on the 16 gigabyte box, just in case. Maybe that job eventually only ever uses 4 gigs of memory, and every time it's run, you're wasting 75% of that machine. In the end, we decided to kind of do the container size by job over time. We initially started with smaller containers, and we were kind of pushed into doing container sizes by job as we learned more about the jobs themselves. We also figured out that we can use that knowledge elsewhere in our system. Worker sizing for autoscaling groups is a common paradigm that is useful pretty much everywhere that uses autoscaling. As a compute-oriented big data company, that is useful all over the place for us. We also noticed that some challenges are product agnostic. This is actually not a Jenkins-specific problem. It's something that we felt while we were working with Jenkins, but this is domain-specific. And so it was useful for us to realize that as we were working with a system, that we can divide the problems into domain and product problems or product challenges. And when figuring out whether or not we need to kind of adjust the products that we're using, adopting new ones, we should figure out that product decisions should be based on product challenges, product problems. Ideally, they all solve the domain level problems. If they don't, they're probably not going to be a successful product. Also, many problems that we face while implementing and working with a product like Jenkins, they may feel like they're associated with the product, and that affects the developer experience of the individuals working at the company. And so when you're making a design, when you're implementing a solution, consider the users who are using it. There's the whole field of UX where we care a lot about the end users, the people who are sitting in front of their Chrome browsers saying, how do I feel about this button being this color or in this place? There's much less focus on How does it feel to be a developer working on your command line or in your Jenkins terminal or Jenkins UI? How does it feel to be using that product? Developers are people too. We should really consider their experience as part of a functional, usable, successful, enjoyable system. Another specific challenge we were facing in our implementation was logging. Jenkins doesn't aggregate its logs. You kind of have to go into an individual job to search around. We could ship everything to an aggregator like Datadog, but that would be very expensive given the number of logs that it generates. We could create log filters so that we only ship certain logs, the ones that we think are most important. Turns out that just takes time. Takes a lot of picking and choosing what works and then maintaining those filters. It turns out over time we didn't feel that we really needed that aggregation. So far we have not implemented filters. The lessons we learned, this high agency tool actually lets us solve these problems. But our restriction was engineering hours and dollars. It just shifts the limitations from product limitations to monetary limitations. All right, so let's talk a little bit about stuff that's more about Jenkins itself. The knowledge base of Jenkins, it's okay. There are, I would say, loose documentation. There is some at the lower level, for simpler implementations. The documentation for Jenkins is pretty good. It has a lot of the initial like tutorials and guides. Their blogs are pretty good, but as soon as you get into the nitty-gritty details, there's a lot missing. It's kind of painful to find out that like these groovy methods to actually make this thing work, they're just not documented anywhere. Maybe there's documentation that shows you what methods are available, but not anything about their typing, what they actually do, just that there is a method. There are also some odd recommendations within the docs. To have a system that kind of touts its ability to be basically groovy oriented, where you can write whatever you want, and then it says, write as little groovy as you possibly can. It feels a little weird. I was always shocked at reading some of the recommendation docs where it says, just take all of your jobs, all of your pipelines, and make them as few shell scripts as you can. I feel like that kind of defeats the purpose of having this orchestration system that can build these DAGs of jobs to kind of work together. There's also a lot of exposed complexity and overhead knowledge that's kind of expected to make it work. Declarative versus scripted pipelines. Initially, you might wonder why those exist. Why do you even need to care about the difference between them? What is a non-CPS method? Why do you care? Why do you need to know about the serialization of objects between different modules? Like, you shouldn't need to know that. It should just tell you. It should give you a good error message, but it frequently doesn't. Just knowing that certain things are compatible between Groovy and Java, you just shouldn't need to know. Lessons learned, consider documentation in product selection. If you're choosing between multiple products, really read the docs, go through tutorials, figure out if you want to be reading this for the next 5 years. If you're frustrated reading it, maybe it's not the best place to be. Also, in that process, search the internet for common problems. See if they pertain to you. There's going to be times where problems with a product don't. Maybe there's this big problem with this particular feature that you just don't care about. That's okay. But if you're seeing that there's a common problem with a feature that you're going to be using every day, every hour, maybe look elsewhere. And also, when documentations make a strange suggestion, stop for a minute and think about it. Maybe try and figure out where that came from. Maybe query the internet, maybe query other companies, ask your friends. It's worth looking into. Some technical limitations we found with Jenkins were a little bit of plugin inflexibility. Most of the time things work as desired, but then you get some things where like Blue Ocean, which is the core pipeline representation plugins, basically supported main by Jenkins through their documentation. If you have a nested parallel block in your Jenkins pipeline, it will not represent it right. It just won't do it. That kind of stinks. You can still kind of figure out what's going on by going through the large single massive log where every single branch spits out in order of it running, but it's not nice. Also, slow work delegation. We found that the worker containers are delegated jobs, and it takes sometimes like 30 seconds ish to delegate a single container. When you have a pipeline that runs a bunch of single nodes in a row and they use the same container, that's not a problem. It just reuses it. But if you have these cases where you have a bunch of pipelines that split jobs apart into parallel blocks, each of those starts adding up, and you can get pipelines that would take much faster in, say, GHA. Something that could take like 2 or 3 minutes might take 20 minutes in Jenkins. This also is probably likely the result of partially because of our implementation using the ECS containers instead of having workers co-located with controllers and so on. So what do we learn? Every product is inflexible in some way, or every product has limitations in some way. Even the ones that seem very, very, very flexible, there's going to be something that kind of blocks you. Flexibility itself may also cause other problems, as we talked about with the high agency. And every design decision is a trade-off. Consider when you are making a design decision, consider what you're giving up. Lastly, we have debuggability. I find the debuggability of Jenkins to be pretty challenging, especially because of the logging situation. Also because of our containerization distribution situation. Actually finding or replicating events that are happening in a Jenkins container is pretty hard. We don't have container-based local development at our company yet, and so making an identical environment to the runtime environment is not it's not done for us, and so it's a challenge. It is a large distributed system. There's some amount of randomness involved. Some of the bugs that we do find in Jenkins, like worker disconnects, swallowed logging, double trigger jobs, seem to happen randomly. In reality, nothing is truly random, but from the developer's standpoint, it feels random when something just breaks once, works on retry. Not a good feeling. So what do we learn? We should prioritize creating local dev environments that match runtime environments. It's good to be able to say, if this thing breaks, I want to be able to reproduce it either on my machine or, we were talking a little bit earlier about doing development in the cloud. Being able to replicate that environment is very, very helpful. And also, nothing's 100% reliable. That's okay. A reliable organization expects some failure, and we can work with it. Yeah. Let's do a quick review of what we learned. So high agency, high effort. Again, not always. We're moving towards a place where that's not always true, but in many cases it can be. So consider the idea in something where you're given the keys to the kingdom, or rather a product that claims to give you the keys to the kingdom. If you are a startup and you only have a couple people, Jenkins may not be the ideal product for you. Look for something that kind of handles a lot more of the heavy lifting. Effort upfront, effort versus effort on demand. This is a classic. I hope everyone knows this one, but it's good to reiterate. Doing a little bit more planning, every hour you put into planning will hopefully produce or reduce the amount of effort you have to do fixing a problem in production. In the case that you have a very wide open situation, a very wide open product, set guardrails for yourself. Write documentation, share it, create plans up front, make sure everyone's on the same page. Ideally, you still have developers over process, people over process, but having the process is still good. You still want to have the process to follow, to then break away from if it doesn't fit your situation. Use the right tools for the job. Focus tools tend to be better than general tools when you have a focused problem. Sometimes when you have a problem, it's me, not the product. Make sure you're holding the product correctly. And documentation. When it doesn't exist, write it, share it. Finally, every system has its challenge. We've used Jenkins, GitHub Actions, Travis CI, Atlantis, Argo CD, and a bunch of others. And these systems, they all have their strengths, their limitations, their weaknesses, and places where they are good. That's just life. And also, the grass isn't always greener. The number of times we've heard, hey, let's just like take everything and move it over to GitHub Actions. I hear it's better. That isn't always going to work. Sometimes some things will be better on a different system. Try to figure out when it will be. Figure out if you're facing a domain problem or a product problem, and maybe move a little bit over. Figure out what the products will benefit you when you use them. And that's my spiel. If you have any questions about Jenkins or want to do whatever, I'm here. Thanks, everyone.